Welcome to another exciting educational video brought to you by Upvision Concepts Academy. So in chemistry today, we'll be looking at chemical industries, and we'll see how most of these chemicals are produced industrially and the processes or the name of the process involved. So today we'll be diving into Haber process, contact process, and procedures for manufacturing fertilizers and other chemical products. So sit tight and enjoy the video. If you're not subscribed to this video, kindly hit the subscription button to subscribe and get more of our lessons. So we'll dive in. Chemical industries actually are sectors that apply chemicals process to convert raw material to useful products. These industries are vital to national development. Yes, as they produce essential goods such as fertilizers, soaps, glass, cement, industrial chemicals. Yes, and so if we want to understand how it functions, it's crucial for our growth and even for our exams. So the first industrial process that we'll quickly dive into is the Haber process. The Haber process. Now, this process was developed by Fritz Haber, and it is used for the production of ammonia. Production of ammonia gas. One that ammonia is a very, very vital chemical used in our laboratories and used in our industries. And the reaction that is involved in the production of ammonia is nitrogen gas combining with hydrogen to give us ammonia, and this actually is an exothermic reaction. Remember when we did energy enthalpy, the enthalpy energy there is a minus 92 kilojoule per mole. Okay, so this is actually exothermic. From the word exothermic, heat is given out. So the environment where the reaction is happening is hotter than inside of the reaction. So it's going to be very, very hot. Very, very hot. You need to have a cooling system for what is coming out. So the conditions is that the temperature will reach close to 500 degree. Temperature is about 450 degrees Celsius. Very, very hot. The pressure where it will be happening is at 200 atmosphere, and the catalyst that is used to drive this reaction is finely divided iron catalyst, iron ore. Okay, finely divided iron, finely divided iron, cuprum, sorry, iron, Fe. Okay, so the raw materials actually is nitrogen from air. This nitrogen is from air, and the hydrogen from methane or water. So these are the raw materials. So if you are asked what raw materials are used for the Haber process, hydrogen from air and methane from water. Sorry, methane or water from gas. Methane or water. Okay, so what are the uses of ammonia? The first one I have here is it is used as fertilizer. Okay, manufacture of fertilizers. Okay, let me get us to see clearly. Okay, so these are the uses of ammonia. Ammonia is used for manufacture of fertilizers, Urea, ammonium nitrate. Secondly, it is used for production of nitric acid, and thirdly, it is used as cleaning agents. Okay, so the next process that we shall conversant with is the contact process, and the contact process is used for the production of sulfuric acid, the production of sulfuric acid, H2SO4. And the processes for getting this is, the first thing you will do is to burn sulfur in air. Burn sulfur in air. Burn sulfur is an element in air. Okay, so the reaction is sulfur plus air will give us sulfur 4 oxide. Okay, so the next thing is to do oxidation of sulfur oxide to trioxosulfate. So the next one is the oxidation. This sulfur oxide, oxidation of sulfur oxide to sulfur trioxo. Okay, so when we do that, you have sulfur oxide in presence of oxygen as catalyst. It will give us this. Okay, the catalyst is actually Ammonium 5 oxide at a temperature of 450 degrees centigrade. Okay, so after the oxidation, we now have absorption of what I have here in hydrochloric acid. Okay, so not hydrochloric acid, sulfuric acid. So we absorb this, absorption of SO3 in H2SO4. Okay, so the formula for that is this plus H2SO4 will give us oleum, this oleum. Okay, so this oleum, but this oleum now is what we will now dilute in water. We'll dilute in water, dilution with water. So we can have oleum plus water to give us tetraoxosulfate acid. So see the process from burning sulfur in air, it goes to oxidation of sulfur oxide. When you burn sulfur in air, you get sulfur oxide. So oxidation of sulfur oxide will give us a sulfur trioxo, and okay, so when we get that, in presence of this catalyst, you now have sulfur oxide trioxo will give us plus sulfuric acid to give us oleum. So oleum is the intermediate product, but what we're looking at is to get dilute sulfuric acid. So by the time you pass it through water, you get your final product. So what are the uses of sulfuric acid? Number one, again, is to manufacture fertilizers, also detergents, and paints and dyes, then battery acid. These are the uses. Fertilizers, detergents, paints and dyes, and acids. So there are other products that we can get industrially, like soap production, is through a process known as saponification. I'll put that on the board. Saponification. So this other one is soap production. When you hear of the word saponification, it is actually making of soap. And the process involves heating fats and oil with sodium hydroxide. Heating fats and oil. Heating fats and oil with sodium hydroxide. So when you do this, you are producing soap. You get soap and glycerol. Types of soap, you have hard soap from sodium hydroxide and soft soap from potassium hydroxide. So the last one we'll look at soap production is detergent production. There are two different things and different process. For detergent production, we are looking at synthetic detergents are made from petrochemicals like alkyl benzene. So this is where you get detergents, petrochemicals, sulfonic acid as well. So when you neutralize with sodium hydroxide, you get detergents. What are the advantages over soap? You say the two of them washes. What are the advantages of detergent over soap? They are both different, but detergent have advantage over soap. Okay, so what are the advantages? Number one, work well with hard water. Work well in hard water. Okay, number two, more foamy and effective. More foamy and effective. No, you agree with me that this is it's practical enough even for an effective, sorry. Very practical enough. You can try that. You see that detergent is easier to use than soap. Okay, so we look at glass production. So, okay, for glass production, the raw materials required to make glass is silica. Silica is from sand. Silica is silica. Again, I have sodium carbonate. Sodium carbonate. Okay, so this is in effect sodium carbonate. And limestone. Limestone. These are the raw materials for making glass. So when you ask in the exams, which of the following are raw materials that are used for glass? Silica is there, sodium carbonate is there, and limestone is also there. So the process involves the raw materials are heated in a furnace to about 1,500 degrees, very hot, okay, to form molten glass, which is then shaped and cooled. So from heating this combination at this particular temperature in a blast furnace, you will get a molten material which can be molded into shapes, put in glass mold. For instance, I can have a mold like this. I pour it inside, I get a glass cup, and so on and so forth. Understand? Okay, so what are the uses of glasses? For windows, for bottles, for mirrors, for laboratory equipment? You know, the list is endless. So cement production. From the raw materials we need here is limestone. This is limestone. And we also need clay. Clay has in it aluminium oxides and silica. So this is clay combination. Understand? The process involves mixing and crushing the raw materials. Everything just mix and crushing them. Heating in a clean to form a clinker. So you heat in the clean to form a clinker. When that is done, you grind the clinker with gypsum to form cement. So cement is used for construction. We all know that. It's used for construction. And finally, under this topic, we are looking at fertilizer production. And here, the raw materials that we need to produce fertilizer is ammonium nitrates. Ammonium nitrates. Okay, sorry. Before I go, that's just common types. But before I go into the common types, the production is actually done by mixing nitrogen. This is the element, nitrogen, phosphorus, and potassium. I know your agricultural studies, you will hear of things like NPK. So NPK, nitrogen, potassium, phosphorus. nitrogen, phosphorus, and potassium. So these are the elements. So common uses or common types is ammonium nitrate, urea, superphosphate of lime, and NPK blends. Okay, so these are common fertilizers. So we have seen all the various industrial processes and production. Chemistry is actually a very interesting subject, and it's a very wide area of application. So in our comment description, you will see NECO, JAMB, or WAEC-style questions bordering on this topic. And if you like what we are doing, please like our page, like our videos, and also make some comments to engage us. Subscribe if you're not subscribed. So I hope this video has been informative for you. I'd like to thank you for viewing.